Demystifying OSPF, a deep dive into OSPF. This video provides an in-depth exploration of the Open Shortest Path First, OSPF, routing protocol, a cornerstone of modern network infrastructure. We'll unravel the intricacies of OSPF from its fundamental concepts to its advanced features, empowering you to design, implement, and troubleshoot OSPF networks with confidence. We'll cover OSPF areas, LSA types, and the mechanics of LSA flooding, painting a complete picture of how OSPF achieves scalability, robustness, and fast convergence. Prepare to embark on a journey that will transform your understanding of OSPF and its role in shaping the Internet. OSPF core concepts, building blocks of efficient routing. Dijkstra's algorithm. At the heart of OSPF lies Dijkstra's algorithm, a powerful tool for calculating the shortest path to every destination within the network. OSPF uses a cost metric, typically derived from bandwidth, to determine the most efficient routes. Cost metric for path selection. Bandwidth influences cost calculation. Adjacencies and LSAs. Routers form adjacencies with their neighbors to exchange routing information. This information is encapsulated in link state advertisements, LSAs, the fundamental building blocks of OSPF. Adjacency. Neighboring router relationship. LSAs. Carry routing information. Reliable communication. OSPF implements several mechanisms to ensure reliable communication, such as supports VLSM, CIDR, and authentication. OSPF hello packets every 10 seconds on broadcast, 30 seconds NEMA to verify connectivity. Database synchronization ensures consistent routing info. Through database synchronization, OSPF ensures that all routers within an area possess a consistent view of the network topology, enabling accurate path calculations and preventing routing inconsistencies. OSPF areas a hierarchical approach to scalability. ASBR connects to external networks. ABR connects areas to backbone. Internal router resides within a single area. OSPF employs a hierarchical design using areas to enhance scalability and manage complexity. At the heart of an OSPF network lies the backbone area, Area 0, serving as the core for all other areas. Non-backbone areas must connect to Area 0, creating a structured topology. Area border routers, ABRs, act as gateways between areas and the backbone, summarizing routing information and ensuring connectivity. Internal routers operate within a single area, maintaining detailed knowledge of the local topology. Area types, backbone and standard, the foundation of OSPF. Backbone area, Area 0. Core of OSPF network. All areas must connect. Standard areas. Internal routers. Connect to backbone. Receive summary routes. The backbone area, Area 0, forms the very foundation of an OSPF network. All areas must connect to the backbone to maintain proper routing functionality. Standard areas contain internal routers and connect directly to the backbone, receiving summarized routing information from it. Standard areas rely on the backbone for inter-area routing, enabling efficient communication across the OSPF domain. This structure allows OSPF to manage large and complex networks effectively. Special area types, optimizing routing in specific scenarios. Stub areas. No external routes. Totally stubby areas. No external or summary routes. NSSA. Limited external import. OSPF provides special area types such as stub areas, totally stubby areas, and not so stubby areas, NSSAs, to optimize routing in specific scenarios. Stub areas block external routes, relying on a single default route for destinations outside the OSPF domain. Totally stubby areas go a step further by blocking both external and summary routes, simplifying routing tables even further. NSSAs offer a compromise, allowing limited external route import while still maintaining a degree of stubbiness. Transit areas cannot be configured as stub. These special area types enable administrators to fine-tune OSPF behavior and optimize network performance. LSA Types 1 and 2, the building blocks of OSPF topology. Type 1, Router LSA. sent by each router with directly connected links. Type 2, Network LSA, sent by DR on broadcast networks. OSPF utilizes various LSA types to disseminate routing information throughout the network. LSA Type 1, Router LSA, is sent by each router, advertising its directly connected links and their associated metrics. LSA Type 2, Network LSA, is generated by the designated router, DR, on broadcast networks, listing all routers present on the segment. These LSAs are crucial for constructing the link state database and determining the network topology. LSA Types 3 and 4, Inter-area routing with summary advertisements. Type 3, Summary LSA, advertises routes to other areas. Type 4, ASBR Summary LSA, advertises ASBR location. To facilitate inter-area routing, OSPF employs summary LSAs. LSA Type 3, Summary LSA, is sent by ABRs to advertise routes to other areas, providing a high-level overview of the network topology. LSA Type 4, ASBR Summary LSA, is also sent by ABRs, specifically advertising the location of Autonomous System Boundary Routers, ASBRs. These summary LSAs enable routers to make informed routing decisions without needing detailed knowledge of every area, thereby enhancing scalability and efficiency. LSA Types 5 and 7, Connecting to the outside world with external routes. Type 5, External LSA, originated by ASBRs, advertises external routes. Type 7, NSSA External LSA, originated by ASBRs in NSSAs. OSPF provides mechanisms for incorporating external routes into the routing domain. LSA Type 5, External LSA, is originated by ASBRs to advertise routes to networks outside the OSPF autonomous system. LSA Type 7, NSSA External LSA, is used in not-so-stubby areas, NSSAs, allowing ASBRs within these areas to inject external routes, which are then redistributed as Type 5 LSAs by the ABR. This controlled injection of external routes enables OSPF to seamlessly integrate with other routing protocols and connect to the wider Internet. LSA Type.
Name. Generated by. Scope. Purpose. Type 1.
Router LSA. Every OSPF router. Inter-area. Lists interfaces and neighbors.
Type 2.
Network LSA. DR on a multi-access network. Inter-area. Shows connected routers on a subnet.
Type 3.
Summary LSA. ABR. Inter-area. Advertise routes between areas.
Type 4.
ASBR Summary. ABR. Inter-area. Route to reach ASBR.
Type 5.
External LSA. ASBR. OSPF domain. External routes, e.g., from BGP. Type 6. Group membership not used anymore. Type 7. NSSA External. ASBR in NSSA. NSSA only. Used in NSSA instead of Type 5. LSA Flooding. Ensuring consistent routing information. Flooding. LSAs are flooded throughout an area. Controlled. To prevent routing loops. Sequence numbers. Track LSA freshness. Aging. Remove stale information. To maintain a consistent view of the network topology, OSPF employs LSA flooding. LSAs are flooded throughout an area, ensuring that all routers possess the latest routing information. This flooding process is carefully controlled to prevent routing loops and ensure stability. Sequence numbers are used to track the freshness of LSAs, and stale LSAs are aged out to remove outdated information. The flooding mechanism is to refresh LSAs every 30 minutes. OSPF, a robust and scalable routing solution. Hierarchical. Uses areas for scalability. Scalable. Efficiently distributes routing info. Robust. Key for modern networks. OSPF stands as a hierarchical, scalable, and robust routing protocol, ideally suited for modern enterprise and service provider networks. Its use of areas and LSA types enables efficient distribution of routing information, while its robust flooding mechanism ensures consistency and stability. By mastering the concepts and techniques presented in this overview, You can harness the power of OSPF to build high-performance, resilient networks that meet the demands of today's dynamic environments.